All right, guys, let's take a look at page 333. So with all these logarithms we've been talking about the last 2 days, we're going to go over some properties that these have, like how can we combine logs together, how can we make kind of one complicated log, more than one easy log to work with, kind of break it up. Can you guys complete this sentence for me? Logs are exponents or powers. Good. Okay, so since logs are exponents, and we already are familiar with properties of exponents, properties of logs are going to be very, very similar to those. So that's what we're kind of going to look at first, just to kind of get the easier ones taken care of, and then we'll get into the ones that are a little bit more tricky. So let's say we had two exponential expressions or terms that were being multiplied together, okay, assuming their bases were the same. What would you do with the exponents? If you're multiplying the same base, how can you combine the exponents? Maybe we'll think of an example, like if we had 5 to the third times 5 to the 7th, what would you do? Yeah. You add them. Okay, so we would add exponents. So this would be 5 to the 10th. What if we had two exponential expressions that were being divided and we knew they had the same base? What would you do with the exponents? Yes? Subtract them. All right, so for instance, if we had 5 to the 7th divided by 5 to the 3rd, that would be 5 to the 4th. We're familiar with those two. Those are kind of the two big ones, okay? What's interesting is that we have similar properties to those for logarithms, so we're going to kind of check those out in these two boxes here. Now, let's try to think about in our heads, remember logs are powers. What power do you have to raise 3 to get 9?
Good morning.
Good morning. Anything for the office today? I think we're good.
Okay.
Thank you. Can you think of it? Say it again.
Square.
A squared, a power of 2. Okay. What do you have to raise 3 to get 3? Yeah. 1. All right. And then 2 plus 1 would be 3. Let's check out this one. What power do you have to raise 3 to get 27? Yeah? A cubic, or a power of 3. Okay. So notice how these are the same. But what do you think we can do to these two separate logs to get this one log? Do you notice a pattern, something that can be done? What do you think?
You can multiply the two arguments together.
Right. Perfect. Notice how if you did 9 times 3, you would get 27. So this is what's kind of similar to this property of exponents. Notice how if you're adding logs, which are essentially adding exponents, right, you can multiply the arguments together. Okay, we're going to write that down here in a second. Okay, let's check out this one. What power can you raise 2 to get 32? Yeah? 2 times 16, but what we're thinking of 2 to what power could give us 32? It's okay. Yeah?
12.
Say it again?
12.
2 to the 12th power
Oh, wait.
is 32?
Wait. Hold on.
Yeah? 5. 2 times 2 times 2 times 2 times 2 would be 32. Good. So that one's 5. What about 2 to the 2 to what power would give you 4? Yeah, 2. And if we subtract those, looks like we get 3. What power can you raise 2 to get 8? Say it again. 3. Okay, notice how those are the same as well. Okay, so take a look at this set. What can you do to kind of these, or what operation can you do to these logs in order to get this one? Do you see a connection? Yeah.
Divide them because 32 divided by 4 is
You're going to divide the arguments, right? 32 divided by 4 gives you 8. So we have this way to kind of condense logarithms. Instead of maybe adding 2 together or subtracting 2 together, we can multiply the arguments or possibly divide the arguments to change those into one log. So just like up here with our property of exponents, if you are dividing the same base, we said subtract the powers. Notice how if you're subtracting the logs, you can divide the arguments. Okay, very similar connection between exponents and logs. So we're going to go ahead and formally kind of write down these 2 properties, and then we're going to discuss kind of 3 more. All right, so let's take a look at this one. In a general case, we don't really have numbers anymore. Notice how the bases are the same. So if you're adding the 2 logs together, how can we turn this into one log? What would we do? Yeah. Multiply the arguments. So this would be m times n. Now yesterday we kind of introduced the concept of a natural log. A natural log is still a log, so it's going to have all these same properties. So this would end up being the natural log of a times b. Do we remember the base of a natural log? Yeah? 2.718, aka, yeah? E. Good. Okay, so let's go ahead and write that in words. We'll say when 2 logs of the same base are being added, we can multiply the arguments to make one log. All right, let's check out the next one. We are subtracting 2 logs together that have the same base. How can we turn that into one logarithm? Yeah? You would be dividing. Specifically, the first argument divided by the second, m divided by n. Same property would hold true for natural logs. So this would be natural log of a over b. Okay, so in words, when 2 logs of the same base are being subtracted, we can divide the arguments to make one log. Do we see the connection to those 2 log properties and the exponent properties that we're already familiar with? Multiplication and addition are kind of linked, and then subtraction and division are linked. Okay? The other 3 are kind of new to us, so it might take some time for us to get used to them. But we're going to go ahead and maybe think about what's going to happen. I think number 3 might be a little easier for us, so is 5. 4 is going to be definitely new. Can we think about this in our heads? Okay, in the general case, what power do you have to raise b to get b to the n? Maybe I'll write this down. You don't have to write it down. I want you to think about it. What power do you have to raise b to get b to the n? What would this have to be in order for these 2 sides to be equal, aka exactly the same? Yeah. An n. Right. Okay. Maybe you want to check it out on your calculator if you wanted to. If we use the common log, what's the base assumed to be? 10. All right, so let's go ahead and say, what if we did log with a base of 10, and then the argument was 10 to the 9th power? Notice how we would get just that power of 9, okay, which is exactly what's going on here. We're just getting the power. So what's nice about this one is if the base of the log matches the base of the argument, those kind of cancel each other out, and you're just left with that power of n. Same thing going on here. Notice how the base of a natural log is e. We have a base of e in the argument. Those would cancel, and we're just left with the power of n. So they're kind of like inverses. They're canceling each other out, just like you would add 3 and subtract 3. A log is basically canceling out an exponential. We're going to talk about that relationship a little bit later in this unit. Okay, so maybe in words we'll say when the base of the log matches the base in the argument, the answer is the power. Maybe we'll be more specific, the power in the argument. Note to self, I got to give myself a little bit more room to write those in. Are you able to fit those in now? You guys can write a little smaller? Okay. All right, let's go ahead. We're going to skip number 4 just for now. We'll come back to it. Let's check out 5. Knowing what we just did in number 3, can we think about what we would be left with here? Notice how it's a little switched. Instead of taking the log of an exponential, we now have an exponential with a power that's a log. Can you think about what we might be left with in either of these two cases? You want to give a guess? Yeah. It'd just be a, right. Notice how the base of the log matches the base of the exponential part. Very similar to what we were talking about here. So those would cancel each other out, okay, just like inverses, and we'll be left with that argument of a in either case. All right. Again, if you wanted to check it out on your calculator, we can think of an example. Maybe 10 to the log base 10. Notice how the base of the exponential matches the base of the log, and we'll just type in 6. Whatever number you want. Notice how we just get 6 out. So the base of the exponential is canceling out the base of the log, which is just resulting in whatever's left in that argument. Okay, so in words we'll say when the base of the exponential, someone's excited, matches the base of the log, the answer is the argument. Are we doing okay so far? Okay, I think the first two, I know they're new to us, but hopefully they make sense because they're related to the exponential properties. 3 and 5, they are new to us, but I think they're kind of simple because if some things are matching, we can just kind of cancel them out because they're inverses, they undo each other. This number 4 is a little different, okay? Because nothing really matches here. Notice how the base of the log does not match the base of that exponential. Okay, they're not exactly the same. But if we do have a power in the exponential, this fourth property of logs tells us we can take that power and move it out front or as a multiplier, kind of as a coefficient. So this would look like n times log base b of a. This is sort of related to another property of exponents. Whenever you have a power to a power, how do you combine those together? For instance, if I had 5 squared to the third, what would that be? Yeah? You multiply them, right? Okay, and aren't logs powers? So notice how this log, which is essentially a power, is being raised to a power. We can multiply those together, those powers together. So it's very related to that other property of exponents. Same thing can go on for natural logs. We can bring the power out front as a multiplier. All right, so in words, maybe we'll say the exponent of the argument can become the coefficient, meaning number in front, of the log. All right, so we have 5 properties of logs that we're going to practice today and tomorrow. Okay, if we're adding 2 logs together with the same base, we can multiply the arguments. If we are subtracting logs with the same base, we can divide the arguments. If we happen to notice that logs and exponentials have the same base, they simply cancel each other out, and we're left with either the power or the argument, whatever is kind of left over in that case. And then the fourth one was if we have a power, we can move it out front as a coefficient. So we're just going to practice these today, get comfortable with them, because we're eventually not going to have this list to reference. Okay, we're going to have to be familiar with all 5 of these properties. All right, so let's take a look. Maybe in some cases we'll just start with numbers, and then we'll go into some variables. But the properties work either way, whether you have numbers or variables. So let's take a look at the first one. Notice how we have 2 logs being added together, and they have the same base. So using one of the properties, we should be able to turn this into one log that has the same base. What can we do? Yeah. Multiply what? When you say them, what do you mean? The arguments. Okay, so we need 6 times 8/3. And maybe we can simplify that. 6 times 8/3 would be 16. All right, maybe we can think about this in our heads. What power can you raise 2 to get 16? Yeah? It's okay. 4. Yep, there we go. So what's nice about these properties is if we tried to solve the original 2 in our heads, we probably wouldn't have been able to do it. Can you think of a power you can raise 2 to get 6? Probably not. And you probably can't think of a power to raise 2 to get 80 or 8/3. So even though we can't simplify the original 2 in our heads, if we use a property to kind of condense it, turn 2 logs into 1 log, notice how we were able then to figure it out in our heads. No calculator necessary. So these properties are really nice, or a really nice way for us to simplify the logs into more easier logs to work with, or to even figure out in our heads without using a calculator. All right, let's take a look at the next one. What are some things you guys notice in this logarithmic expression? Some things you want to do. Go ahead, Rebecca.
Well, it has, in front of the log is like 2 different numbers.
Okay, so if we have a number in front of a log, where can we move it to? Where was it originally? Yeah. It was the power of the argument. So this is a log base 3 of x to the 1/3 minus log base 3 of y squared. All All right, if it starts out as a power in the argument, you can move it out front, or vice versa. If it starts out front, you can move it to a power in the argument, back and forth. So that's one property. Can we use another one? Can we start condensing? I have two logs being subtracted, and they definitely have the same base. How can we turn those two logs into one log? Yeah.
You can just divide x by 1.
There we go. I love it. All right, let's check out number 3. Stepping it up a bit. Now we have 3 logs in there. They're all the natural logs, so they all have the same base. What do you think?
Wait, for the last one,
Yeah.
we have to make it equal to anything.
Say it again.
Why don't we have to make it equal to anything?
Like equal something?
Yeah.
Okay, so this one we were actually able to solve in our heads because we had numbers to work with. This one we have variables. So we don't, like 3 to what power would give us x to the 1/3 over y squared. You don't really have that connection between the two, okay? So this one we were able to solve, but this one we just simplified, okay? What about 3? Do you see any properties we might be able to use? They're all the natural log, which means they all have that same base of e. You want to try, Hannah?
You could take the natural log x and subtract that to the natural log x to the 3rd, so that it would be natural log x to the 1/3, because you have to divide.
Okay. So she noticed that we are subtracting. This would be the natural log of x divided by the natural log of x to the 3rd. Can we simplify that in our heads, though? If you have x over x to the 3rd, how many x's do we have left, and where are they? Yeah? -2, so you can write x to the -2nd, or 1 over x squared. Okay, they mean the same thing. All right, so we turned the last 2 logs into 1 log, but we still haven't really done anything with the first one, and that was being added. Can we keep going? Can we use another property? You see it, Tori?
So we can distribute the ln since ln is x.
Not quite, okay, and I'll show you why. That's a common misconception. So let's check it out. If we did, for instance, the natural log of 8 plus 6, we get 2.639, okay? Tori was wondering, well, what if we distribute kind of the natural log in, kind of like that? They're not the same, okay? So it seems like whenever you guys see parentheses, you're used to distributing, but it's not necessarily the case for logs, okay? But it's a good question. How can we condense these 2 logs, though? Can we turn these 2 logs into 1 using one of our properties? If you're adding 2 logs together, what do you want to do? Yeah. Multiply the arguments. Good. Okay, so this x plus 2 times 1 over x squared. The x plus 2 would simply move to the numerator, because you can think about it as x plus 2 over 1. And then we'll have our ending log. So we went from 3 logs actually down to 1 log. Okay, this is going to come super in handy when we start to talk about solving log equations. We did simple ones yesterday, but we're eventually going to amp it up where we have 2 or 3 logs in an equation, and we're going to have to kind of condense it into 1 log to help us solve. Okay, so these are really important properties. We need to be able to go from 3 or 4 or 5 logs all the way down to 1. All right, let's try number 4. Bless you. Anything you guys want to combine, simplify, rewrite? Do you see any properties we might be able to use? Yeah.
For the middle one, we could carry the 2.
Okay, we can carry the 2 as a power. So this would be log base 3 of 3 squared. Do we know what 3 squared is, though? 3 times 3? Maybe we'll write that as 9. All right, so that was one property. We move the 2 up as a power. Can we keep going? Go ahead. All right, we could multiply the first two. So log base 3, and that would be x times 9, or aka 9x. All right, so we started with 3 logs. Now we're down to 2. We got to do one more, get down to 1, yeah? Divide the arguments. So log base 3, we'd have 9x over y. Do you guys want to try the 5th one? See how you do? All right, use the properties. We got to go from 3 logs down to 1. All right, let's see how far you guys got. We'll do baby steps, okay? Because notice how for some of these we did do multiple properties to get them down to 1. Let's see what we can do here. What did you guys notice first? Good, Maddie? Okay, and what'd you do with those numbers? On the argument? Perfect. All right, I like that. Good first step. What'd you try next? Good, Rebecca?
I divided the natural log of x to the half power divided and y squared. So I got the natural log in parentheses. I had x to the 1/2 over y squared
Okay, looks good.
minus, yeah.
Good. All right, so if we're subtracting 2 logs that have the same base, we can divide the arguments. Love it. So now we're down to 2 logs. We got to use another property to get down to 1. You want to keep going, Rebecca? Yeah?
Well, you also have to divide the natural log of g, so I just put that on the bottom.
So we got to take this fraction divided by z. Okay, so this is when it can get a little complicated because you're dealing with fractions and division. If you're dividing by z, it would simply just move to the bottom where the y is, or y squared is. So we'd have the natural log of x to the 1/2 over y squared z. That'd be your final log. How did we do on the first step? Did we move those numbers? What about the second one? Were we able to condense it down to 2 logs? I could see the third one being a little tricky because of the division, but did we handle that okay? All right, we doing okay? Confident with the properties? Ish? We're going to keep using them, okay? This time we're going to kind of do them backwards. So in the first 5 examples, we started with multiple logs and condensed it down to 1. Let's go the other way. What if we just start with 1 log? How can we expand it into multiples? Okay, so more practice with these properties. So in this case, I know it's not really written in parentheses, but your argument is considered the xy squared. So if you were to kind of read that argument out loud, most of us would probably say x times y squared. So let's think about a property. If you're multiplying in the argument, how could you expand the log? Yeah. Add the arguments in individual logs. So this, we could expand it as log base 3 of x plus log base 3 of y squared. Yeah. We could use another property. Yep, we can move that 2 out front of its log. All right, so we're kind of going reverse now. We're going to start with 1 log and then expand it based on what the argument looks like using those properties. All right, let's go ahead and try the next one. Again, the argument, sometimes it's in parentheses, sometimes it's not. In this case is x times the square root of y. How can we take that 1 log and expand it using some properties? Go, Tori. Okay, so the square root of y, you can rewrite it as a 1/2 power. Love it. Anything else we can try? Yeah.
You can move the 1/2 power in front of the natural log of y.
There we go. Good. All right, so we're expanding, turning 1 log into multiple logs based on what that argument looks like. Let's amp it up a bit. Take a look at 8. We have the natural log of AB divided by c squared. How can we break up that log? Yeah.
Make it the natural log of AB minus the natural log of c squared.
Okay, if you're dividing in the argument, you can break it up using subtraction. All right, that's a good one. Can we keep going? Can we use any other properties? You see something? Yeah.
You can turn it into the natural log of a plus b.
Right. This argument is still being multiplied together, right? A times b. So we can break this natural log up with addition. We'll have the natural log of a plus the natural log of b. Anything else we can do? Yeah. We can carry the 2 out front. So we actually had 3 properties we used in that case. All right, let's try 9. 1 log, we want to break it up or expand it into multiple logs. What do you notice in the argument and how can we use a property? Yeah.
The first one we would do would be log x cubed minus log y.
There we go. So if we are dividing in the argument, we can break up the argument into 2 separate logs. Remember the numerator's written first. You see another one?
You can break up the log yz and do log y minus log z.
Okay, so you said minus, which you are correct, but if you're multiplying 2 things together, how do you break it up? You add them. Okay, so you said minus, which it's actually going to turn into a minus in a second. This is what's a little tricky, okay? In this first line we wrote here, notice how we're subtracting this entire log. So if we expand that log, we should be subtracting whatever that expansion is. And if we expand it as log y plus log z, if you wanted to simplify, you would have to distribute that minus in there. A little tricky. Some of us would forget to put in those brackets or a parenthesis set. Okay, but if you're subtracting a log, however you expand it, all of the expansion should be subtracted as well. Okay, so I like it so far. So Hannah, if you wanted to distribute, it would then turn into a minus like you said. Okay, any other property you notice we can use? Yeah. We'll bring the 3 out front. All right, so 3 log x. Maybe we will distribute in that minus log y minus log z. We're doing okay so far? All right, we're going to save number 10 for tomorrow kind of as a refresher. Maybe some of you want to try it to see how you do, but that's kind of like the mother lode of all of them, if you ask me, okay?